In this video, I will show how to graph a quadratic function by analyzing its factored form. So in our case, we have a quadratic function given in standard form, and to write it in factored form, I have to factor out this quadratic trinomial. So first I'm going to take out the negative, and now I can easily identify the factors. So the function written in factored form looks like x minus 2 times x minus 4, and all that is negative. So from this form, I immediately identify two things. First is the stretch factor. So the stretch factor is -1, and that means my parabola opens down and has no stretch. So it's just a standard parabola. Now, the next thing is x-intercepts. They are 2, 0, and 4, 0. I simply read it off the equation. It's what we subtract from x becomes the 0 and the x-intercept. Now, once we know x-intercept, we can easily find the axis of symmetry. Axis of symmetry is the vertical line passing right between the x-intercepts, so we can find its equation by averaging out the x values of x-intercepts. So x equals 3 is the equation of this line. And now once we know the axis of symmetry, we know the vertex. We know where the vertex is. And to find the y value of the vertex, we just evaluate the function at 3. So 3 minus 2 is 1, 3 minus 4 is -1, 1 times -1 times negative is 1. So the vertex is at 3, 1. So now we're ready to graph this function. We're going to start with the vertex at 3, 1. X-intercepts are 2, 0, and 4, 0. And the stretch factor is -1. That means parabola opens down and looks something like this. Now, to find the y-intercept, we simply have to evaluate the function at 0, which is not that hard. So 0 minus 2 is -2, 0 minus 4 is -4. -2 times -4 is 8 with a negative, so it's -8. So this is my vertex. These are my x-intercepts. This is the axis of symmetry. And this is my y-intercept. So this is how you analyze quadratic function given in factored form.